Today we're going to learn some laboratory techniques in physics. All right? We're going to convert a galvanometer to be used to take readings of current as if though it were original ammeter. So in some laboratories, we have more copies of the galvanometer than the ammeter. So in such instances, a lot of instructors will want to go to the market to buy more of the ammeters. But you don't need to waste your resources. All you need to do is to get a few copies of the galvanometer and then convert them to be used as ammeter. And that process of converting a galvanometer to be used as an ammeter is called a shunting. All right, you can shunt the galvanometer. And what is shunting? To shunt is to construct a resistor of very low resistance parallel to the galvanometer. All right, as you can see this simple circuit, the line is coming like this from other parts of the external circuit, and then the current gets to the junction A or to the point A. Because there are two lines, the current is subdivided. This single current is now divided into two. There is a current through galvanometer, and then this one is passing through the shunt. Okay, so the current will pass like that. Then two of them will meet at point B, and then the journey continues to the external part of the circuit. Now, when this arrangement is carried out, and you use resistor of very low resistance, all right, arranging it in parallel with the galvanometer, galvanometer is now reading as an ammeter. So if you look at this simple circuit, which is a technique in the laboratory, we can actually write some equations that can help to solve some problems, any problems that involves a galvanometer and a resistor that is connected parallel to the galvanometer. So one of the equations we can directly write out from this arrangement is the fact that a single current that is going like this gets to point A, and then it is subdivided into two currents. So we can write that the total current is equal to the current that is passing through galvanometer plus the current that is passing through shunt. So this one is your equation 1. All right, we use it for calculations at different points. Then another equation we can write is at point A. At point A, the potential difference at point A, PD across G, that's the potential difference across this line, across galvanometer, is equal to PD across the shunt, right? Equal to the potential difference across this line, right? Of course, in electricity questions, this assumption is always consistent with the natural theory that the PD across one arm is equal to the PD across the other arm when there is a branch in a circuit. So please take note of this. So using Ohm's law, which says that potential difference V is equal to the product of current and resistance. All right, with the Ohm's law, we can apply it here. So the PD across galvanometer is equal to PD across shunt. And so if you bring in Ohm's law, we are going to have current of galvanometer times resistance of galvanometer is equal to current of shunt times resistance of shunt. So this is another equation that could be written from the diagram above. And these two equations can always help us to solve problems. This is how a galvanometer can be converted in the laboratory to be used as an ammeter. I hope you learned something.